Hello friends, we are still not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to do a lead code easy problem called maximum subarray problem. Let's understand the problem statement. We are given an array of integers with both positive and negative values, and we need to find a continuous subarray which has the largest sum and return the largest sum that we find in the given array. So let's try to understand the problem with an example. Say we are given an input array like this: 1, 5, -7, 8, 3, and -1. Over here, if we try to do the sum of first two elements, we get a value of 6. And if we try to add the third element in our continuous subarray, the total sum becomes -1, which we really don't want. So basically we can say that up until this point, the total sum of this entire subarray is actually negative. So it does not make sense for us to continue with this particular subarray. So we can move on to the next one and we can drop this subarray and we can try to see that in future can we find a potentially subarray that has better sum. And so far we have determined that the maximum sum we can make in this triplet pair in this first three entries is 6. So we can say that our current maximum value that we can achieve is 6, and we will start moving forward. Over here we can see that we have 8 and we have 3. The sum of it is 11, which is definitely more than our current max. In fact, 8 by itself was more than our current max, so we would have updated our current max. And now if we add 3, it becomes 11, which is much better. If we move on to the next value, we see it's -1, and our total sum would become 10, which is less than our current max. And in the brute force, this is the approach that we would take. Suppose we are given an input array from the example. Now, from the looks of it, we know that the maximum possible value we can get is 6, and we get it from this 4 continuous values. 4 -1 plus 2 plus 1, which turns out to be 6. But let's see what could be the brute force approach in this scenario. So in brute force, what we can do is we can simply take every single subarray, try to make sum of it. So all these values, we will keep adding the values and we will keep track of the maximum value that we find. And once we are done with this one, we would again start the same thing with second value, and we would continuously keep on making new pairs, and we would be adding our max value, and eventually we would find a combination, which is this one, where our max value would be 6, and we would be able to return this answer. This is a really inefficient uh, way of doing things, and if we see the time complexity, it turns out to be big O of n square, which is a big no-no, and we should try to find a better approach. However, if we change couple of things in our given example, we can we can understand that there is a better approach available. Now let's see what could be the better approach. In this approach, we can try to use some mathematics to our input problem. Suppose if any given value, if we encounter that sum of that subarray becomes negative value, then it is not in our best interest to continue on with that subarray, and it's better to drop that subarray and move on to the next one. Let's see how can we use this logic in our given example. So first of all, the value by itself is negative. So it does not make sense for us to continue with this subarray. So we can drop this value. We can move on to next one. So 1 is positive value, and whatever values that comes down further, if they are positive, keeping 1 would be in our interest, because it will always add the value to our maximum subarray. So we can keep this in our current subarray, and we can move on to the next value. So the next value is -3. So 1 plus -3 actually becomes -2. So we can say that the value of this subarray is actually -2. And if we were to continue down this path, even though all the values are positive, still this -2 is going to cause us to have lesser value. So again, it is not in our interest to keep this value. We move on and we simply drop all our subarrays until here, because this is not useful to us. Let's clean this up a little bit. Okay, now again, let's start with the next subarray. Over here, we can see that the value is 4, which is positive. So we keep it. If we see the next subarray, it's actually 4 plus -1. So again, value is 3. That is still positive value, and it is in our interest to keep this subarray for now. The next value is 2. So our current subarray value becomes 3 plus 2 equals to 5. And if we keep on going, the next value we encounter is 1. So 5 plus 1 becomes 6. So all of this so far looks really good because we are continuously having positive values and we are our gaining the value of our subarray. Now let's see what would happen if we add -5 to it. And also, when we are doing this calculation, on the side, we would keep a parameter called max value, and we would continuously checking that what is the maximum possible value we are getting out of the subarray. So initially the value would be 4 over here, and then the value would be 5, and next the value would be 6. Now, if we move forward, we are still seeing that it is actually -5. So the value becomes 6 plus -5. So again, the value is 1, which is still a positive value. So we keep it in the current subarray and we move on to the next value. If we see the next value, it's actually 4. So the value becomes 1 plus 4 equals to 5. So the entire sum of this whole subarray is actually 5, but we already established that the best sum we could find in this given subarray was for this portion, and it was actually 6. And since we have created an additional variable where we store its value, so we would be able to simply return this, and it would basically provide us with our answer. So let's see what is the time complexity for this problem. So we are just doing everything in a single iteration. So time complexity is big O of n, which is a much better time complexity than our brute force approach. And if we see the space complexity is actually big O of 1, because we are using constant space, and we are not using any additional data structure or any other place to store any additional data. This is a really efficient approach, and this would be our optimal solution. Now let's move on towards coding. Okay, let's do the coding for the given problem, maximum subarray. As mentioned earlier, we will start by having two variables, one to store the current sum and one to store the maximum sum. So current store, we will initialize it to 0, and maximum sum, we would initialize it to the first element in the given input array, because we are guaranteed to be given at least one value. Now let's traverse through the given input array by a for loop. So first of all, we will check that whether our current sum is negative or not. If it is negative, we basically reset the value of current sum to 0. Now we just need to add the current value to our current sum. So our current sum becomes, now we just need to check that whether our current sum is the maximum sum that we can get. Now we simply return the maximum sum. Let's try to run this code. Let's try to run it again. Looks like it's working. Let's try to submit it. And we can see our code runs pretty fast, and it's a really simple solution to our problem. Thank you for watching.